All right, so now we are going to move into a washer method. And the washer method is finding the volume of a disk with a hole in it. So remember when we did disks, it started off to be a circle with thickness of dx, correct? Okay, so now we are going to have an outside circle and an inside circle. And so we'll want to find the area of this outside circle, subtract inside circle, that'll give us this area, and then we'll add on the thickness with the dx. So everything to find the area of a circle, it's not looking too much like a circle, but it is a circle. So you always want to start with outside radius. So the outside radius would be all the way out to here. Then the inside radius would be this inside distance from here to here, right? The smaller green R. So the volume of one washer would be pi r squared, right? So if I want to find the area, so pi outside radius squared minus pi inside radius squared, that would give me the area. And then if I add on the thickness of the washer, the dw, or the dx is what we're going to use for the dw, then I would find the volume of one washer. All right, so then of course we integrate it because we add up n of them, and then we let the number go to infinity. So we need to make sure we square each of the radii separately. So let's look at this graph here. So if I have y equal root x, looks like that, and y equal x squared, looks like that. That's the part we need. All right, so we're going to be revolving it about the x-axis. So let's get our rectangle here. So rectangles are perpendicular to the axis of rotation. So if this spins around, so the outside goes out to here and the inside is here. So it's really important you make this the center and you see the outside and inside radius. Okay, so volume by washer, I'm going to encourage you to set up the framework. Squared minus squared dx. All right, so the outside radius squared will be from the center to the outer radius here. So the center to go all the way out to here, that's capital R, that would be root x. Then if I want to find the inside radius, that would be from the center to this distance here. That would be the inside radius, and that is x squared. And then I can see that I'm going to start building them at x equals 0 and end building them at x equal 1. I'm not giving you the work here, but I just wanted to show you how I came about. All right, so let's look at this one. So I want to find the area bounded by, let's look at y equal 2. Y equal 2 looks like this. And y equal 4 minus 1/4 x squared. So it's a parabola shifted up 4, right? And the 1/4 here just makes it a little wider of a parabola. All right, so we're spinning it around the x-axis. So this is center. All right, so again, you build the rectangles, this is the area that's bounded. You build the rectangles perpendicular to the axis of rotation. So if this is center, make it center, right? So make the big thing. So that's the inside radius right there, right? So let me just put the little r there. So from here to here is the little r. All right, and so then make the outside radius. If it goes on top of some of your writing, that's okay. Let it go. And then the outside radius, let's use the black here, go all the way out to here is the capital R outside radius. All right, so pi outside radius squared minus inside radius squared dx. All right, so the outside radius is from the center out to the blue parabola, so that's the 4 minus 1/4 x squared. And the inside radius is from the center up to the red line, this green distance here, so that's just 2. And then if I set them equal to each other, so I have 2 is equal to 4 minus 1/4 x squared. So that gives me 1/4 x squared is equal to 2. X squared is equal to 8. So x is equal to plus or minus root 8. So negative root 8 to positive root 8 are the two x values that I'm starting to build rectangles and where I'm ending to build rectangles. All right, let's look at our other different axes. Let's save that for next time.